Hello everyone, welcome to the final project presentation for Intro to Material Science. I chose hexagonal closed packed structure HCP as my final project topic, and so I'm going to present details and examples of HCP in this presentation. Here are the subtopics that I'm going to talk about in this video. We're going to see how HCP is different from other major crystal structures and see HCP's 3D models and stacking sequence, and learn how to calculate APF, atomic packing factor. Additionally, we'll look at 4-parameter Miller-Bravais lattice coordinates. Lastly, we'll look at some metals that have HCP structures and how they are being used in our life. In class, we covered simple cubic structure, body-centered cubic structure, face-centered cubic structure, as well as hexagonal closed packed structure, and we're going to focus on HCP. Here are the 3D models that I created on Tinkercad. Unicell is the smallest repeated volume, which contains the complete lattice pattern of a crystal. If you look at the second model, you'll see how each particle has 6 immediate neighbors in a hexagonal shape. And this is the lattice structure with open space. A lattice is an ordered array of points describing the arrangement of particles that form a crystal. The stacking sequence of HCP is easy to see. It starts with the first layer A and then layer B. The third layer is a repeat of the first layer, and the fourth layer is the second layer repeated, and so on and so on. So it has an AB, AB, AB pattern. Now we'll look at how the atomic packing factor of HCP can be calculated. Atomic packing factor is defined by volume of atoms in unicell divided by volume of unicell. It tells you what percent of an object is made of atoms versus empty space. So it basically shows how tightly packed the atoms are. Here's my 3D model of HCP structure. Let's say that the height is C, and one side of the hexagon is A, which is equal to 2R. For the volume of atoms, we just need to do the number of atoms, which is 6 times the volume of a sphere, 4/3 times pi times r to the third power. Next, for the volume of a unicell, we need to do area of hexagon times height. For the area, it's easier if you think of it as finding the total area of 6 equal triangles. So we do 6 times square root of 3/4 times a squared and then times c. Using the information that for ideal case, c/a is 2 times square root 2 over square root of 3, and putting them all together, we end up with about 0.74 for the atomic packing factor. I also wanted to go over how the directions for HCP structures are expressed. So you read of projections in terms of unicell dimensions, A1, A2, A3, and Z. If you look at this example, it goes 1/2 in the A1 direction and 1/2 in the A2 direction, and 1 in the negative direction of A3, and 0 for Z direction. You change these numbers to integer values, and then this dashed in line indicates a negative value. HCP is really important because it is one of the most common crystal structures. Some metals with HCP structures include beryllium, cobalt, cadmium, magnesium, zinc, and titanium. Beryllium is used in gears and cogs, especially for use in aerospace and defense. For example, windshield frames and other structures in high-speed aircraft and space vehicles, aircraft and space shuttle brakes, satellite mirrors, and space telescopes. Next, cobalt can be magnetized and so is used to make magnets. It is alloyed with aluminum and nickel to make powerful magnets. Other alloys of cobalt are used in jet turbines and gas turbine generators, where high temperature strength is important. 80% of cadmium currently produced is used in rechargeable nickel-cadmium batteries. Cadmium was often used to electroplate steel and protect it from corrosion. It is still used today to protect critical components of airplanes and oil platforms. Next, magnesium is used in products that benefit from being lightweight, such as car seats, luggage, laptops, cameras, and power tools. As magnesium ignites easily in air and burns with a bright light, it is used in flares, fireworks, and sparklers. Lastly, most zinc is used to galvanize other metals such as iron to prevent rusting. Large quantities of zinc are used to produce die castings, which are important in the automobile, electrical, and hardware industries. That's it for my presentation. Thank you for listening.